All right, it's time to start the class. What questions do you have? Ew. Today we're going to do the chain rule. This is section 3.6. If you recall, last time I even tried to do the chain rule. I wasn't really thinking about what we were doing and tried to do it myself. The chain rule is this. d over dx f of g of x is equal to f prime of g of x times g prime of x. That's it. Pretty simple. Let's see if I can give you some intuition why it's true. Just a little bit of intuition. So, here I have a 3D picture. It's supposed to be coming out of the board. And I'm going to label this axis x. This is going to be g of x. And here we're going to have, this will be y. And we're plotting f of x here. And so here is g. This is g of x. We're plotting the x-axis here in g, and we're plotting it kind of coming out of the plane. That looks nice. And then here will be this here. This is f of g. There's f of g of x. And so when we take a derivative, what we're really doing is we have some value a here. And we're looking at the value a in g. And then we plug it into, this is g of a. We plug that into f. And so this is f of g of a, right there. There's f of g of a. Perspective looks better when I'm standing this close to the board. So anyhow, now what we're going to do is we want to know what happens when we move a little bit from a. So here will be, this will be a, there's a plus h. And this makes a little triangle, a little right triangle. And this distance here is h. And this distance, God, my perspective is really off, but that's okay. This distance here is going to be g prime of a times h, because you go up a slope of g prime as you go over h. Right? This is the slope of the line here. And so we have, so now this distance here is g prime of a times h, which means we're going to get a little right triangle here. This is g prime of a times h, and then this is going to be the derivative at g of a times g prime of a. And so then once we have this picture is going to be a little, you might have to sit and think about this picture a little bit. You ask yourself, well, how does y change as x changes? Remember, delta means change. Well, how much did x change in this thing here? How much did it change? Just h, right? Plus h. It just changed h. And then when I change this by h, it changes this function by g prime of a times h, which then it's put into the change here, which changes this function by f prime of g of a times g prime of a times h. So this is going to be f prime of g of a times g prime of a times h. The h's cancel, and we get f prime of g of a times g prime, oops, parenthesis, of a. This is the chain rule. This is what you got to memorize. Now, of course, memorizing the formula isn't quite the same as being able to apply it. What questions do you have about this, by the way? What is it, the fifth? Is it the 5th week now? 6th week! 6th week, which means if we were on the quarter system, we'd only have 8 weeks left, right? So only 8 weeks left. That's fantastic, because there's 14 weeks and whatever. So, okay, we can do this. We can survive this. Let's do an easy example of the chain rule. All right, so here's what we're going to do. We're going to do 1 plus 2x. We're going to take the derivative of 1 plus 2x to the 5th. Now, do we need to use the chain rule to do this? No, why not? I could multiply 1 plus 2x by itself 5 times. But is that pleasant to do? No, that's no fun. In fact, you'd probably want to use the binomial theorem. Do you guys remember that? Pascal's triangle and everything, right? We don't want to do that. So the chain rule gives us a way out. What the chain rule says is, hey, you find 2 functions here where this is a composition. So f of x is going to be x to the 5th. And g of x is going to be 1 plus 2x. By the way, when you actually do the chain rule, when you get good at it, you won't do this step. You'll just plow through it and write down the answer. We're just starting with this so you can see what's going on. All right, so there we go. We have those 2 selections. Let's do this. So the derivative of this is equal to f prime of g of x. What's f prime of x equal to? Let's see. F prime of x is equal to 5x to the 4th. And g prime of x is equal to 2. So we're going to have 5 times 1 plus 2x to the 4th times 2. What do you think? Is it okay? Thumbs up, anybody? It's okay? Thumbs up in the back? Excellent. That's what I was waiting for. All right, so that's an easy example. Let's do a slightly more complicated example. This one that I like, that we're going to do next. Let's compute d over dx of the square root of 1 plus the square root of x. Let's do this one. Now there's lots of choices here. You have lots of choices on how you do this problem. And the choice I'm going to make probably, it might not be the easiest, I'm sorry. But just pay attention, just go along with it, okay? I don't have much time to talk to you guys, and so let's just do what I want here. So f of x, it's my party, equals the square root of x. F of x equals the square root of x. And I'll say g of x. Now, I could do 2 things. I could say g of x equals 1 plus the square root of x. That might be the easiest, but I'm going to say g of x equals 1 plus x. Oh yeah, how do I, he says, how do you do this? And I say, aha, because now this is equal to derivative over of f of g of f of x. Nobody likes this but me. We'll do it both ways. Okay, here we go. So we could also say h of x equals 1 plus the square root of x. Right? So I have 3 functions on the board, and I could also say that this is equal to f of h of x. Do you guys agree with this? Does anybody agree with this? Does anybody agree that this is the right answer here? Does anybody agree that this is the right answer? Okay, 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 now we're getting someplace. So now let's see if we can do it both of these ways. Now you might say, well, why don't we just do it the easiest way? And the answer is because I want to guide you through a slightly harder example. That's really why we're not doing it the easiest way possible. What were you going to say? You looked like you were going to. I have no idea what's going on. Okay. Oh, and I forgot something. I'm not respecting the equal signs. Respect the equal signs, Bart. There we go. So now I'm respecting the equal signs. Okay, so let's do it. Let's do this one first. This one that I think we all agree is the right answer. So here I go. So f prime of x is equal to, oh, what's f prime? It's 1/2 x to the minus 1/2. You guys agree? Excellent. And then g prime, oh, so we're doing h, my bad. H prime of x is equal to, it's equal to the same thing. Is that right? So now, f prime of h of x times h prime of x is equal to 1/2 times 1 plus square root of x to the minus 1/2. Yeah, why not? Times 1/2 x to the minus 1/2. People are telling me that's correct, and I believe them. All right, now let's do it the other way. Now, to do it the other way, we have to use the chain rule a couple times. So check this out. The derivative of f of g of f of x, 1, 2, 3, 1, 1, 2, 3, is equal to f prime of g of f of x times g prime of f of x times f prime of x. I'm just applying the chain rule over and over and over again. Is it okay? If not, I'll just try to explain it better. If so, then I just keep on going. I don't care. Yep, I'll repeat what he just said. You do the prime, you take the derivative of the whole thing. Bam. And you leave what's inside protected. It's inside. And then you take that inside thing and take the derivative of the outside. And then you take the inside thing and take the derivative of that. And you just keep on going. And look, what's the derivative of x, by the way? 1. So it's like you just keep on going for, oh, don't take the derivative of 1 and then multiply it by that. That'll make it, forget that. Okay, so now, what happens here? F of x equals square root of x. Okay, so what's f prime? Well, we've already taken it. What's g prime equal to? G prime of x is equal to 1. Okay, so now here's the answer. So I can just write it down. 1/2 times 1 plus the square root of x to the minus 1/2 times, what's g prime? 1 times f prime. Wow, this worked out beautifully. It's exactly the same thing. 1/2 x to the minus 1/2. Do you see how this is exactly the same thing, except you didn't have a 1 here? What questions do you have about this? It's the chain rule. Oh, yeah. I'm going to erase this, because it's in my way. Can I erase this? Nobody's saying anything. 1 second. OK, sure. Good? Good? I'm erasing it. Now, typically, if you solve this problem, you might try to use the quotient rule on this. But you don't have to. You can use the chain rule. Why not? So the chain rule would say that this is equal to x cubed times x squared plus 1 to the minus 1. Now, what rules do we have to use at this point? We got to use the chain rule, the product rule, and the sum rule, and the power rule. The power rule is going to have to be used. OK, so let's do it. This is equal to 3x squared times x squared plus 1 to the minus 2. Oh, whoa. To the minus 1. I'm using the product rule. Plus, that's the derivative of this one times this one, plus x cubed. Now take the derivative of this, times minus 1, x squared plus 1 to the minus 2 times 2x. What do you all think? Why didn't I take the, what? Oh. He says, why? He says, Bart, why don't you use the chain rule here, right? And the answer is that I don't see anything I can plug in for x here that's going to make my life easier. Right? Does that make sense at all? OK, good. The cool thing about the quotient rule is that it separates the numerator and the denominator. It really treats them as separate entities. While the chain rule, you have something inside and you have something outside. And that's what makes it kind of complicated. So where you really need the chain rule is with square roots, because you don't know how to expand those out. But of course, what if I had something like this? D over dx of sine of cosine of x. This is like our prototypical chain rule example. Sine of cosine of x. So it's pretty obvious what f is, right? It's sine of x. And g is cosine of x. And so by the chain rule, this is going to be derivative of sine is cosine. Cosine of x times the derivative of cosine is negative sine. So minus sine of x. Is it good? Let's keep on upping the ante a little bit. All right, so let's do the derivative of e how about e to the tangent of x? What's this going to be? E to the tangent of x times the derivative of the thing inside, which is secant squared of x. Yes?
When we have like an expanded function, like to get the derivative, like if we have everything written out, do you want us to simplify it?
Do not simplify. Yeah. Yes. She asked me to explain it, but let me just reiterate your point. When all the if we ask you to take the derivative and all the d over dx's and f primes are gone, you've taken the derivative. Do not simplify. Should you simplify? No, because it confuses and angers the grader. If you like get the right answer and then you simplify and get the wrong answer. It's like, oh, what do I do now? Right? So don't do that for sure. So just don't simplify. We like that. Calculators, we kind of know how to use them. Okay, let's talk about this real quick. So here, f of x is equal to e to the x, and g of x is equal to tangent of x. And if we recall the chain rule, which I'm going to write up over here again, I probably should have written it over here in the first place, but, you know, coulda, shoulda, woulda, I guess. Equals f prime of g of x times g prime of x. And so what's the derivative of e to the x? Yeah, so f prime of x equals e to the x. And then what's the derivative of what's g prime of x equal to? Secant squared. And so now we just plug this in to, this is the plugging in maneuver, okay? You're going to plug this in to the chain rule formula. And I don't know why I'm erasing this, I'm going to write it up here. And you're going to get, let's see, f prime is e to the x, right? So it's going to be e, and it's f of g of x, so e to the tangent of x times, this whole thing times the derivative of tangent, which is secant squared x. Let's see if I can find an even harder problem for us to do. Like I'm looking for one that just is terrible. Maybe I have one over here. Oh, wow. Yeah, let's do the derivative. Okay, ready? That's not even so terrible. Okay, what about this one? 100 over 100 minus x squared to the 3/2. We want to take the derivative of this with respect to x. Now, what rule are you tempted to use right off the bat? Quotient rule. And you can't, that's fine, but you're still going to have to use the chain rule, because to be able to use the quotient rule, you have to be able to take the derivative of the denominator by itself, right? And to take that derivative of the denominator, you're going to have to use the chain rule. So let's do that. Let's use the quotient rule. And the quotient rule says here's what I'm going to do. I'm going to write it out. I'm going to write it out fast. And if you have a question, I know it's embarrassing or whatnot. I don't know. But if you have a question, just say, hey, I want you to explain that step better, and I'll do it, OK? That's the way we'll try that. So quotient rule. Always do the easiest thing first. Square the denominator. So that's what I'm going to do. And look, it's 3 over 2. When I square the denominator, I get 100 minus x squared cubed. I think I did that right. Now, it's the quotient rule. Is it high d low or low d high? Which one comes? Oh, low d high. OK, well, that's great because this low thing is hard for me to write down. X squared. Oh, what's d high? Oh, 0. If I would have thought a little bit harder, I just would have skipped that step and just written 0. And then what symbol? Do I write one of these symbols or one of these symbols? Yeah? Yeah? Minus. Very important. Minus. And then it's high. OK, 100. Hello. D low. All right, so for the compute d low, here's where I have to use the chain rule. So the chain rule says it's going to be 3/2 times 100 minus x squared. What's 3/2 minus 1 is to the 1/2 times the derivative of the inside. 100 minus x squared is, minus the derivative is minus 2x. Bam! What do you guys think? Is it OK? Should I? Yeah, please. Why did I square the denominator first? Well, to start, the quotient rule says x over g of x is equal to g squared. Don't write that. G of x squared, low g of x times f prime of x minus f of x times g prime of x. So by the quotient rule, that's OK. I mean, like I'm sure so I use 2 basic derivative rules at once. I don't really think about when I'm using the sum rule, I guess. What do you guys think? Is it OK? We also used the power rule. What do you think? You have a look on your face. Sad. Sad. Yeah. What did I make f of x and g of x here? Good question. To start, I'm going to have to be a little careful when I answer the question. I need you to clarify. I have a question for you. We did 2 rules. We did the chain rule, and we also did the quotient rule. For the chain rule. OK, in that case, what I'm going to do is I'm going to write it down again and be very clear about how we pick this. So I'm computing the derivative of 100 minus x squared to the 3/2. So I say f of x is equal to x to the 3/2, and g of x is equal to 100 minus x squared. So now, that's the worst 2 ever made. There we go, 2 there. So now f prime of x is equal to 3/2 x to the 1/2, and g prime of x is equal to minus 2x. And so now I'm going to plug all that back into the chain rule, and we'll see what we get. It's going to be 3/2, that's that 3/2 right there, times something I don't know, to the 1/2. And then that something is g of x, 100 minus x squared, that's right, times g prime minus 2x times g prime of x. Is that what I wrote down over there? Ooh, it looks like I did it right. Yes? Can I square 3/2 for you? Boy, Uh-huh. Uh-huh. Okay, so, yeah, I was stuck in a loop there for just a second. I think, maybe I'm wrong, but let me just think about this for a second. If I have, if I raise a to the b, like this, right? Doesn't the rule say that it's x to the a times b? Right? And so he says, he had a good point. He said, hey, Bart, I believe that 3/2 squared is equal to 9/4. And that is true. That is true. But when you have exponents here, right, we have these exponent rules. And it makes sense. And look, if you, I don't know about you, but I used to forget exponent rules. What do you do if you forget exponent rules? I mean, this is common. What should you do? You're taking the second exam, and you're not sure what the exponent rule is. What do you do? Yeah.
You can't just think about it logically.
Okay. How do you think about it logically?
Well, if you have A amounts of X,
Yeah. She said.
and then you have B amounts of
And then if you have B amounts,
those.
I should put some dots in here, of these, right? This is A, and then dot, dot, dot. Yeah, then you have B, then the total number of x's is A times B. It makes sense. That's good. That's good. Is there anything else you could do? Yeah? He said, do I have to use the quotient rule? I'll answer that question in 1 second. All right? Yeah? Right here? Because, okay, I was only working the derivative of g here. That's why. Okay, the other thing you could do is you could type in real numbers. Okay, you could take 4 to the 5th to the 6th and double check that that's equal to 4 to the 30th. You could check, and that would be convincing. All right. This guy, who somebody asked me about why don't I just use the, what'd you ask me again?
At the beginning of the equation, you did a similar one where it was like x cubed over x squared plus 9. You just used the chain rule right into that.
Yeah. He said, why did I do the quotient rule first? Well, I could have, you could have, all of us could have rewritten this as 100 times 100 minus x squared, sorry, equals the derivative. Respect the equal signs part. There we go. To the minus 3/2. And then at this point, no quotient rule needs to be done. But we do have to do a power rule. Minus 3/2. The minus flips it, yeah. She says, could you use the chain rule if you set f of x equal to 100x squared? But then your g of x is going to be 100 over 3/2. So yeah, you could. There's lots of different ways to do this. That would have been fine. Is your hand up back there? Oh. Carry on, carry on. Sometimes I sleep like this, and then both my arms go numb. It's terrifying. It's like I have to like move my arms around and stuff. I can't. It's weird. Okay. All right. Let's see. I have a word problem I want us to work, but let's try to do one more hard derivative, I guess. Geez, there aren't that many hard derivatives. Are these derivatives easy? I don't know. Oh, let's do this one. This looks good. Derivative of sine of cosine. Yeah, let's do sine of cosine of tangent. Sine of cosine of tangent. Now look, the chain rule isn't that bad. You know what rule's a lot worse than the chain rule? The quotient or the product rule. The product rule, they expand things out a lot more. The chain rule, seriously, we're going to be able to belt this out no problem. What's the derivative of sine? Cosine. So it's cosine of, and then you just write this down, cosine of tangent of x. 1, 2, oops, too many parentheses. There we go. And now I looked in here. Now I move in here. What's the derivative of cosine? Minus sine. So it's minus sine of tangent of x. 1, 2, 3. And then what's the derivative of tangent? Secant squared. What's the derivative of secant squared? What's the derivative of secant squared here? So you're going into the test, the next test, and you're saying, okay, I did good on the first test. You see this one, you said, oh crap, Bart never did this problem. He avoided doing derivatives of secants. Probably because he doesn't know what they are. So what do you do? What do you do? You're in trouble. What do you do? Break it up how? It's secant of x times secant of x. Can you tell me more about secant? What is it? It's 1 over cosine. So this is equal to the derivative of 1 over cosine squared of x. This is equal to the derivative of cosine to the minus 2 of x. Do I know the derivative of cosine? Maybe. I know the derivative of sine is cosine. And so the derivative of it's negative sine. That's right. And so now this chalk, it starts off like this, and it ends up like that. Okay, so now the derivative of cosine is, I can do this. Equals minus 2, derivative of cosine is negative sine. Oh, don't do that, Bart. Cosine of x, all to the what? To the minus 1, minus 3 times derivative of cosine, which is negative sine of x. What do you guys think of that? Do you need to simplify this answer? No, don't simplify the answer. Questions about that? Yeah. Yeah, I'm sorry. I know, I just kept on working problems. Good? Yeah. Don't apologize. You guys don't ever need to apologize. He says, where's your answer, Bart? You should put your answer. Here we go. That's the derivative of secant squared. Yeah.
Is the derivative of secant squared x attached to the chain after the secant squared x?
Say it one more time. I'm sorry.
The derivative of secant squared x, like the answer that you put in the pink box, part of the answer there where you touched the secant squared x.
Right here? Or right here?
Or that.
No. This one's done too. Here, this is all, this problem here is done. Boom. Yeah. Uh-huh. Having trouble figuring out what we should pick for that? Yeah. Okay. Let's do another example. Okay. Let's do another example. let's do the square root of 1 plus cotangent squared of x. So now we're going to try a different strategy. What are the two functions here? Well, the one is this. Here we go. D over dx. The first function here is going to be the square root. And then it doesn't matter. I could make it the square root of 1 plus x if I wanted to. Let's just make it this. The square root of the first function is the square root. And the second function is going to be 1 plus something squared. And there's a third function here, and that's going to be cotangent of x, all squared. And so I'm going to write this down one more way. So we have f of x is equal to the square root of x. G of x is equal to 1 plus x squared. H of x is equal to the cotangent of x. Does that make any sense? Okay. So now let's see if we can take this derivative. It might be easiest if we differentiate each of the parts separately. So the square root of x, the derivative is 1/2 x to the minus 1/2. Right? 1 plus x squared, that's even easier. That's 2x. And what's the derivative of cotangent of x? If you don't remember, you could say, well, cotangent of x is equal to cosine of x over sine of x. Is that right? Cosine of x over sine of x? Does anybody agree with me? I see people nodding their heads, sort of, yes. And let's use the, this is cosine of x times sine to the negative 1 of x. And so the derivative, oh my God, the derivative of cotangent, d over dx of cotangent of x is going to be equal to, I'm going to use the product rule. So the derivative of cosine is minus sine of x times sine inverse of x. And then what's the derivative of plus cosine of x times, what's the derivative of sine to the negative 1? Oh, don't write this. Write it up here. There we go. What's the derivative of sine to the negative 1? Well, let's see. It's going to be, we drop down the minus 1. Oh, this is so hard. Cosine, minus 1 sine of x to the minus 2 times cosine. Oh my God, what happened here? This isn't sine inverse, this is sine to the minus 1. What's sine times sine to the minus 1? It's minus, so this is equal to minus 1 plus cosine squared, or minus cosine squared of x all over sine squared of x. What is cosine squared of x over sine squared of x? Cotangent squared. So this is all equal to, oh my God, minus 1 minus cotangent squared of x. But didn't we do this last time and get like an easier answer? How did we do that one? We use the quotient rule. That's the answer. Okay, so now we have all the parts. This is fine. This is fine. This is fine. So we're going to have the final answer is going to be this. 1/2. That's this one here. 1 plus cotangent squared of x times g prime. What's g prime equal to? It's equal to 2 times the inside cotangent of x times minus 1 minus cotangent squared of x. How many times did I use the chain rule there? Well, 2 or 3 times, depending on how you count, right? All right, what questions do you have? All right, let's look at one word. Let's look at one word problem. I like this one. It's on page 189 of your text. It's number 87. Let's see if I can unblank this screen. Ooh, okay. And it says the number of hours of daylight at any point on the Earth fluctuates throughout the year. In the northern hemisphere, right, we have more hours of, well, whatever. The shortest day in the winter is on the winter solstice, and the longest day is on the summer solstice. And they give you this formula that I've typed in to, this is GeoGebra, it's kind of cool, a formula here that tells you if you pick a day, so on January 1st, it tells you how long the day is. And let's see if I can, there. So it's about 9.05 hours at some probably 40 degrees north latitude. Hey, wait! We're at like 42 degrees, right? So that's close for Columbus. Now, of course, this plot doesn't look like very much. It looks kind of like a line. So we're going to need to scale it a little bit. Let's see if I can figure, oh, there we go. How many days are in a year again? Not 2,000. Okay, so now let's see, 360, it looks pretty good. And now, there we go. And so this is our plot here. And this is how long the day is throughout the year. What do you guys think? Does this make sense? In the wintertime, it's less than 10 hours. In the summertime, it's closer to 14 hours. Maybe, I don't know. Let's see, I can move this point around. This point right here. A. Boom. So about almost 15 hours. By the way, this is number 87 on page 189. All right, so the question is, approximately how much daylight is there on March 1st, the 59th day of the year? Let's see, 59th day of the year. Oh man, looks like about 10 hours. And then they say, they want you to compute the derivative. Let me show you the derivative here. I think it will help. F prime of x. Now, of course, to compute this derivative, you have to use the chain rule. Yeah, we can kind of see that this is right. Where's the derivative on my plot here? Why is it, do you see, this is the derivative on my plot. Why is it so flat compared to the other one? Anybody know? The change is very small, right? You're only changing by minutes at a day or an hour or something like this. So here, let's go ahead and see what this looks like. I can take this axis here, if I'm smart. There we go. There's the derivative. And does that make sense? Let's think about this. On January 1st, is the day getting longer or shorter every day? It's getting longer. Longer, until about midsummer, right? And the day's getting shorter. Make sense? All right, we're done for today. Have a nice couple days before you have to